Hi everyone, my name is Evan and welcome to my final year project video. This project is titled A Precision Control Circuit for a High Current Short Circuit Tester. Let's delve into it further. The inspiration for this project came about during my college work placement at Western Automation R&D. Western Automation build, test and validate life-saving electrical safety equipment. One of their main products is the Residual Current Device, or RCD. These RCDs are thoroughly tested and put under stressful conditions to ensure that they are fit for purpose. One of the tests carried out involves putting the RCD through overcurrent conditions and verifying the physical effects the RCD can suffer. The electricity which we use comes in the form of alternating current voltage or AC voltage. It can be represented here by a sine wave. As you can see, a sine wave is measured in degrees, known as the angle. An electrical fault can occur at any point of this waveform, travelling in either direction or at any amplitude. This is also the case for the overcurrent test. The laboratory technicians have little control over where on this graph the test begins. The aim of my project is to simulate the overcurrent test, but improving upon it by adding an additional precision feature which begins the test at a desired angle. This is the architectural diagram for my project. This project's main function is to synchronize with an AC signal and to turn on a semiconductor at a desired point which allows the current to flow to the RCD under test. To achieve this, I designed a control circuit. It uses a PIC microcontroller to monitor and synchronize with the AC signal, and to turn on a semiconductor device known as a thyristor. The thyristor acts as a switch, conducting when the gate receives a trigger from the PIC, and continuing to conduct while the voltage across the device is not reversed. The PIC is programmed with embedded software in the form of C programming language. The PIC is programmed to monitor the position of the AC wave using external interrupts from a zero-crossing circuit. This zero-crossing circuit uses two optical couplers, which both notify the PIC when the current reaches zero, one being when positive goes to negative and negative goes to positive. The timer 1 peripheral on the PIC is used to start the timer between the zero crossing and the point at which the thyristor is to be turned on. The timer 1 peripheral is a 16-bit counter which increments every clock cycle of the PIC. A trigger button must be pressed to begin the test. This sends another interrupt to the PIC. When this interrupt is received and the point on wave is reached, the PIC will turn on the thyristor and current will flow to the RCD. The current that flows to the RCD will be in the form of a pulsating signal. Depending on the desired point on wave value, the pulsating signal will be either from the positive or the negative cycle. This project implements a user interface with the Raspberry Pi 3 to adjust settings for the test. The PIC communicates with the Raspberry Pi via serial communication using the PIC's UART peripheral. The Raspberry Pi begins the test with a Java program which allows the user to input the point on wave value in degrees and the number of pulsating cycles required. A script written in Python on the Pi then communicates this data to the PIC. Another Java program is then called to give the user the option of inputting the data into a MySQL database. Thanks everybody for listening.